Sweden against America in ice hockey. Sweden got 6 goals and America got 2 goals. And so the Swedish goalie, he let in 2 goals. But he actually saved 92% of shots on goal. So he saved 92% of shots on goal. And the question then is, how many shots on goal did he get? Well, what do we know about these 2 goals? These 2 goals must be the 8%. So 8% of the shots on goal went in. So these are equivalent to 2 goals. So 4% of shots on goals would have been equivalent to 1 goal. Just by dividing by 2. Dividing by 2. So if 4% is shots on 1 goal, how do we go from 4% to 100%? We multiply by 25. So we would get 100% of shots on goal would be 1 goal times 25 would be equivalent to 25 goals. So there were 25 shots at goal, 92%, 23 of them he saved, 2 of them went in. Okay? So that's one way of doing that one. Then we have Maria is playing in a hockey team. And the average age of the hockey team. So we have 20 players. And the average age is 20 years. So if we were to add the ages up of all of these people, what's the total age? Well, the total age will be the average age times the number of people. That will give us the total age of all of these people, which will be 20 years times the 20 people. So the total age will be 400 years old. Doesn't matter what the individual ages of those people were, the total number of years of those people in the team will be 400. But then 2 of the players quit. So we now know that 18 players now have an average age of 19 years old. So what's their total age then? Well, the total age of all of the players now would be the 19 years times the number of players, which is 18, which gives us 342 years old. Years in total. So what must the 2, so we have 2 people, let's call them X and Y. The ages of these 2 must be 342, 400 minus 342, must give us the total age of these 2 that quit. And 400 minus 342 is 58 years. So X and Y must be 400 minus 342 equals 58 years old. Now let's assume that they're both adults. So we'll say that X is more than 18. Let's say that X is 18. What would Y have to be? Well, the ages have to add up to be 58. So Y could be 40. X could be 19, Y could be 39. X could be 18, Y could be 38. So this one will increase by 1 each time, and this one will decrease by 1 each time. So it can be any combination. 18, 48, 19, 38, 39, 19, 20, sorry. 20, and 38. So, and then you could just write there continues. But any one of those, just write continues. Plus 1 minus 1 plus 1 minus 1. So any combination of ages that add up to be 58. Then we have Anja Persson. Is a famous Swedish skier. Don't know if she still is famous, but she used to be back in 2006 when this paper was done. She is traveling at a speed of 102 kilometers per hour. Okay, let's write it as kilometers per hour. That's her speed. And then we're discussing that her time, Anja's time, is 0.24 seconds, which doesn't sound a lot, shorter than the second place. And we want to know, how far has she travelled? What's the distance? How much does 0.24 second actually be equivalent to in terms of meters? Not kilometers per hour, we're wondering seconds in terms of meters. So in order to do that, we have to change our units. If we were going to change 1 kilometer to meters, we know that we would times by 1,000, do we not? If we were to convert 1 hour to seconds, 1 hour, we would multiply by 60 times 60, which is multiplying by 3,600. So that's what we have to do, but we have to keep them on the right place of the dividing sign. Notice that kilometers is up here with the 102. So we do 102 times by 1,000, because kilometers is up on the top, it stays on the top here in the conversion. But hours is on the bottom. So the hours to seconds also has to stay on the bottom. This will give us the time in meters per second. And this is the easiest way I think of converting. Keep it as it's written. 1 hour is equivalent to 3,600 seconds, but the hour is on the bottom. So you get the answer directly of how many meters per second is her speed by doing this multiplication. We can see that we're going to get quite a few zeros cancelling here. So we get 1,020 divided by 36 meters per second. That gives us directly 28.3 recurring meters per second. So that's the speed of Anja in meters per second. So how far does she go in 1 second? She'll go 28.3 meters. So in 1 second, she travels 28.3 meters. So in 0.24 of a second, we multiply 1 by 0.24 to get what 0.24 of a second is. So multiply this 1 by 0.24 to get the distance that she travels. Then she'll travel 0.24 times 28.3, 6.8 meters. So she's actually, doesn't sound a lot, 0.24 of a second, but she's actually 7 meters almost ahead of the second place. This is the easiest way I think of doing it. There are alternative ways, but I sort of think, how do I go from kilometers to meter? Multiply by 1,000. How do I go from 1 hour into seconds? Multiply by 3,600. And keep them as they are written in the units. Kilometers per hour is now converted in an easy way into meters per second. Okay, the last one then. I think we'll finish the